All right, guys, there's also another type of law of sines case when you get the sides and the angle and they don't make a triangle, or they make two triangles, or they only make one. And that can be confusing, and this is like the picture from the book. Like it would look like this, and the side here can't like swing in any way to make a triangle. And then, for example, these are the same, and it can swing in and make two triangles. I also have some, I have GeoGebra up here, and I've embedded this into your homework assignment, and I'll show you how to use this too. Being able to decide like if you have one or two or no triangles. So that's a good way to check your work when you're done. So the steps are to use the law signs to find the first triangle. If you get no triangle, you stop, check for a second triangle, and then solve both. So these are pretty important steps that I would write them down, and I will refer back to them. I already know, because I set these up, that this one has no triangle. But I'll make the example for you. You're going to pretend that you don't know that that we don't know how many triangles. So usually when I'm doing these, oh, I think I forgot to mention the most important part. You know that a triangle could be the ambiguous case, and ambiguous means you don't really know what would happen. If you have, remember way back to geometry, and your 9th and 10th grade geometry teacher wouldn't let you call it this, angle side side. Okay, an angle side side triangle. See what it spells. When you have an angle side side like this, angle side side, it could be one of these triangles that has 0, 1, or 2. And so first off, maybe looking out for that. Like when you see that you have law signs, I see that I can have a law of signs here. Is it then an angle side side? And this one is. And so then I'm going to go ahead and proceed with the law signs like usual, but preparing myself for the fact that I could have two triangles. So I'm going to start with this. So sine 30 over 7 equals, and I would do the sine of angle C over 16, and then cross multiply. So 7 times sine C equals 16 times sine 30. Let me get my calculator up here. And then when you do this, make sure I am in degree mode. You would go 16 times sine of 30, and I'm going to get that. So 7 sine C equals 16 sine 30 is this. Divide by 7. What was it? Negative 15 point something. Divide by 7. And then I have sine C equals, let me divide by 7. For some reason, yeah, I did not get it in degree mode. That didn't seem right to me. I'm going to type this in one more time. 16 sine 30 divide by 7, and I get this. Sine C is 1.142, something like that. Remember, to solve, I need to take the sine inverse. Sine inverse of 1.142. In your calculator, you can go second, sine inverse, and I always use this key down here that gives you the answer button, and go, and look what happens. Error, domain. Later in this unit, we will talk about the unit circle, and the biggest that sign can be is +1, and you'll notice this is over +1. So it doesn't work, and that's why it says arrow domain. So this is, for example, if you get this, now you just stop, okay? This one is no triangle. And to show you that, if I go to my GeoGebra, angle A is 30, so I'll put that in here. See if I can get 30. And this is just a little slider, and you can use this. There we go. And then A to B is 16 was the next thing that I have, 16 and 7. So if I go back to here, this would be 16. Hopefully it goes that big. Yep, it does. 16. Hopefully you're better at this than I am. And then this would be 7. There we go. And you can like pull this little thing and check. Does it ever make, and you can see it doesn't, it's not long enough. It never gets to a place where it will connect here and make a triangle. Okay, so there are 0 triangles made by this. Okay, here, hopefully next when it shows up is an example where it has 1 triangle. And this is where I said to the steps, you know, draw your 2 triangles to start with, and you might get 0 triangles, and then you'll just stop, but it's always better to have them both there. And I'm going to check, do I have an ASS triangle? So ASS, I do. So I know there's a chance there could be 2. Oh, and this is an example with 2. I thought I just had 1 with 1. All right, so we will do a 2 example. Draw what you're given in 1 color. And what I mean by that is you will notice that in black I have 2 identical triangles. They each have 30 degrees here, 16, and 10. Those always stay the same no matter what you're doing. So the first thing is to set up your law of sines. So sine 30 over 10 equals sine C over 16. And you're going to cross multiply and get 16 sine 30 divided by 10 equals sine of C. I did that in 1 step really quick. So in my calculator, 16 sine of 30 divided by 10. And then I need to do sine inverse. And you'll notice this one is less than 1, so we're okay there. I get 53. That was for angle C, so I'm going to put a 53 here. Okay, now you need to stop and move over to this one. And do 180 minus 53. Let's see, 180 minus 53.
If Chloe or Deontay White are in the building, please go to door number 8 for your transportation. Thank you.
And then the next thing I need to ask myself is, looking at only my blue triangle, can I make a triangle? Remember, a triangle adds up to 180. So 180 minus 30 minus 127. Do I get anything less than, like, do I still get an angle? And when I do that, I get 23. So I'm going to fill that in up here. Okay, so yes, because how do I find the third angle in this one? In pink, I would also take 180 minus 30 minus 53 to see what was left. This one will be 97. Now you're going to get 2 different side lengths, and I'm just not going to do that, but do another law of sines to get this side and this side down here. And let's go to our GeoGebra here. And I've got 30, 16, and then this one now this time should be 10. So there we go. And again, if I move this, I hope that you can see, oops, I didn't mean to move the whole thing. When it goes yellow, you know that you've done it. And of course, with my pen, I can't get it perfect. But then look, I can swing in here, and then I get another triangle. And so this one makes 2 triangles, and you can see that one has an angle of something, and then this one has a different angle there. One of these has an angle of 23, that's this one, and this one has the angle of 97. Okay, so please be using this to double check your work. And the last one is with 1 case. Maybe if it shows up. So again, I would have prepared myself to set this up and drawn 16, 20, and 30. Just have my 2 triangles ready. Do this one first. So sine of 30 over 20 equals sine C over 16. So I'm going to go 16 sine 30 divided by 20 this time. Sine 30 divided by 20. And then sine inverse to get 23 degrees. And that's what I'm going to put in right here. Okay, and then if I wanted to find this one, right, I would do 180 minus 30 minus 23 and get 127 for this one up here. And now I think the problem is that did I type this in right? Okay, 20. So I get 23. So I need to now take 180 and subtract 23. So right here, I'm going to do 180 minus 23, and I get 157. And then I need to ask myself, can I make a triangle? Well, 180 minus 30 minus 157 would be a negative number. When I do that, I actually get -7. Okay, can I make a triangle with an angle of -7? No. So the second triangle doesn't exist, and this one only has one. And if we do our GeoGebra again one more time, if I can get this all the way out here to 20, and it doesn't go that far, this one would not swing in and create another triangle. This one still does, so I'm not quite far enough. And I can't make it any farther than 15. But I think you understand what I'm saying, that if that was the case, if I could make this green side longer than 20, I would not be able to swing it in and create another triangle over here. So if you can use GeoGebra, use that to help you. So law of sines, ambiguous case, you're always going to check for two triangles. If your triangle is a side angle, as your geometry teacher made you say in 9th grade, I'll allow you to call it an ASS triangle, because that allows you to remember to check for more than one triangle.